Imagine standing beneath the vast expanse of the night sky and witnessing the birth of a new day, one where the light stretches across the heavens. NASA has released images that document a groundbreaking event, wherein a star known as Betelgeuse shed a large portion of its outer shell, expelling an extraordinary quantity of its mass. This rare phenomenon is termed a surface mass ejection, SME. According to the Space Agency, the expelled material weighed 400 billion times more than an average solar flare emitted by our Sun. Scientists have described this occurrence as an opportunity to observe stellar evolution as it unfolds, with a star shedding massive pieces of itself. Shockingly, this catastrophic explosion from the super-red giant has raised questions about many aspects of our understanding of the universe. Why did Betelgeuse lose such a large portion of its outer layers, and what does this mean for the cosmos? Let us delve deeper. Stars are often grouped into constellations, each named after ancient myths and legends, many of which still assist us with navigation today. One such star, Betelgeuse, is among the largest and brightest stars visible in the night sky. This brilliant ruby-red star, known as Betelgeuse, is positioned in the upper right shoulder of the Orion constellation, famously referred to as Orion the Hunter. When examined by astronomers, Betelgeuse reveals itself as a star of great volatility, undergoing a regular pulsation cycle that spans around 400 days. Betelgeuse is easy to identify due to its distinct orange-red hue, which also serves as a reminder to skeptics that stars do indeed manifest a range of colors. Betelgeuse, also recognized as Alpha Orionis, is the second most luminous star in the constellation, following the blue supergiant Rigel. Despite Rigel's brightness, Betelgeuse earns its title of Alpha Orionis because of its intense luminosity, enormous size, and reddish appearance, making it one of the most well-known stars. Notably, Betelgeuse inspired both the name of a fictional character and a popular film. Betelgeuse ranks as the seventh brightest star visible from North America, Europe, and Canada, and holds the 10th position for overall brightness in the entire sky. Earth lies in relative proximity to Betelgeuse, though astronomers still face challenges in determining the exact distance between the star and our planet. Estimates place Betelgeuse's distance between 430 and 724 light-years away. As the most luminous red supergiant star closest to Earth, Betelgeuse stands out in our galaxy. Only about 200 red supergiants have been identified, and Betelgeuse's size is extraordinary. Its radius is roughly 764 times larger than that of the Sun. If Betelgeuse were to replace our Sun, its outer layers would extend beyond the asteroid belt and possibly beyond Jupiter, causing Earth, Mars, Venus, and Mercury to be engulfed entirely. Betelgeuse is a giant, approximately 16,128 times more massive than our Sun and about 126,000 times more luminous, meaning it could be seen from a distance of 548 light-years. The star has a surface temperature of about 3,600 K, which makes it cooler than the Sun. If human eyes could perceive wavelengths beyond what we can normally detect, Betelgeuse would appear far brighter than Sirius, currently the brightest star visible in our night sky. Betelgeuse loses approximately 1 solar mass every 10,000 years. Surrounding the star is a nebula formed by the uneven expulsion of material in all directions, creating a cloud of gas and dust around it. This nebula is estimated to be 250 times larger than the star itself, with a size roughly 30 astronomical units, or 30 times the distance from the Sun to Neptune, the outermost planet in our solar system. While our Sun regularly releases mass in the form of solar flares, the Sun's emissions are tiny portions of its outer atmosphere, called the corona, and are classified as coronal mass ejections, CMEs. These CMEs and surface mass ejections, SMEs, can occur independently of each other. When a star expels a section of its unstable outer layers, it results in a CME, commonly known as a corona CME. The Sun's CMEs happen frequently and can have significant impacts on Earth, especially if the ejection originates from the Sun's side facing Earth. A CME can travel faster than 1,800 kilometers per second, discharging plasma and magnetic fields into space. When a CME reaches Earth, it can disrupt satellites, power systems, and occasionally even pose risks to astronauts. The discovery of Betelgeuse's unique ejection event sheds new light on this type of cosmic phenomenon. In 2019, Betelgeuse ejected material into space, which cooled and coalesced into a dust cloud that obscured the star's brightness, making it harder to observe from Earth. Additionally, Betelgeuse's regular pulsating cycle, which was once predictable, was altered by this event. Unlike typical CMEs, The SME that Betelgeuse released was extraordinary, with mass 400 billion times that of a normal solar flare. This caused Betelgeuse to vibrate intensely, similar to gelatin trembling after being shaken. According to Andrea Dupree, an astronomer at the Harvard-Smithsonian Center for Astrophysics, this event might indicate that Betelgeuse's internal convection cells are out of sync, and the star's outer surface is struggling to re-establish its normal pattern. Scientists have been monitoring Betelgeuse's pulsations for over 200 years, but now those pulsations have disappeared, leading to intriguing questions. Red giants, including Betelgeuse, are all in their final stages of life, and being able to observe this process directly will provide researchers with invaluable insights into how stars evolve and die. Stars, including Betelgeuse, are primarily powered by nuclear fusion, where hydrogen in the core fuses to create helium, releasing a vast amount of energy in the process. As the star ages, the hydrogen fuel diminishes, and helium starts fusing with carbon, creating heavier elements. Eventually, the fusion of neon and iron leads to the collapse of the star, as the fusion of iron absorbs energy instead of releasing it, causing the star to implode. This collapse results in a supernova, one of the most powerful events in the universe, releasing more energy than 10 billion suns. Throughout their lifetimes, stars change colors, from the hottest blue shades to cooler red hues, depending on their stage in stellar evolution. Betelgeuse, which was described as ruddy by the Greek scientist Tusi in 168 AD, may have once been a yellow supergiant, as Chinese astronomers reported seeing a yellowish hue centuries earlier. The ejection event from Betelgeuse may provide important clues to how red stars shed mass as they approach their final stages, just before they explode in a brilliant supernova. As one astronomer pointed out, no massive mass ejection has ever been observed on the surface of a star like Betelgeuse before, leaving us with a phenomenon we cannot entirely explain. It's something entirely new that we can observe directly and study through Hubble. The explosion of Betelgeuse may be imminent, but it remains uncertain whether it will result in a supernova anytime soon. NASA notes that Betelgeuse's supernova explosion is likely to occur within the next 100,000 years, but given the vast timescales in cosmic terms, this may not happen for a long time. Researchers like Sarah Nance and her team have been investigating the potential timing of such an event, conducting simulations to understand how Betelgeuse and other similar stars may behave over time. Why did Betelgeuse suddenly dim and break from its regular pulsation cycle, especially when its supernova is still expected to be far in the future? Betelgeuse has been traveling through the Orion OB1 association and has been noted to move at a speed greater than 1 light-year per year. By February 2020, Betelgeuse's brightness had decreased dramatically, from magnitude 0.5 to 1.7. However, in mid-February 2020, the star's brightness seemed to stabilize for nearly 10 days, only to increase again. By late February 2020, Betelgeuse ceased its fading episode, indicating the dimming was not related to an impending core collapse. Further studies suggested that the dimming could be attributed to a large circumstellar dust cloud surrounding the star, possibly formed by large star spots on its surface. Subsequent studies confirmed this, showing that the dust cloud formed from gas expelled by the star itself. Research using the Hubble Space Telescope in 2022 revealed that the material expelled by Betelgeuse might have created the obscuring dust cloud. This cloud, formed from ejected matter cooling and condensing, hid the star from view, making it difficult for observers on Earth to study. The fading, which began in late 2019 and lasted for months, was noticeable even to amateur astronomers tracking Betelgeuse's brightness changes. Even more astonishing, the star's regular 400-day pulsation cycle disappeared for about 200 days, showing how significant the event was. Scientists have proposed that the star is currently rebuilding its strength and undergoing a slow regeneration of its outer layers, while the interior shakes like a belt that's been struck. This surface mass ejection from Betelgeuse is unprecedented, and the true nature of the event remains a mystery, though it is being directly observed in real time with the help of Hubble. When will Betelgeuse explode? No one knows for sure. It could happen tomorrow, in a few decades, or even in 1,000,000 years. But it's clear that Betelgeuse's explosion won't pose any threat to Earth. The star is simply too far away for its supernova to affect us, with astronomers estimating that a supernova must occur within 50 light-years of Earth to have a significant impact. Betelgeuse is more than 10 times that distance, so the explosion, while dazzling to witness, will not harm our planet. When Betelgeuse finally does undergo a supernova, it will likely provide us with an incredibly bright display in the night sky. For now, scientists are eagerly anticipating the star's eventual eruption and studying the expelled material from Betelgeuse with the help of NASA's James Webb Space Telescope. The data collected from this event will contribute significantly to our understanding of stellar evolution and the forces at play in the death of massive stars. Betelgeuse's recent behavior challenges traditional models of stellar evolution, particularly in red supergiants. The standard understanding of mass loss in these stars has been that it happens in a gradual and predictable manner, but Betelgeuse's violent eruption has introduced an unpredictable and chaotic side to these stellar giants. The mass ejection could be a clue to the final stages of a star's life cycle, helping us understand what causes some stars to end in supernova explosions. By studying Betelgeuse, astronomers hope to uncover the factors that trigger these dramatic changes in stars and refine our predictions for similar events in other stars. Furthermore, Betelgeuse's case highlights the complex relationship between a star's core and its outer layers. Observing how these layers interact during mass ejections could offer valuable insights into how other supergiants evolve and explode. This understanding has broader implications for studying galaxies and the distribution of elements across the universe. Finally, Betelgeuse's situation illustrates the importance of multi-wavelength observations, as instruments like the James Webb Space Telescope and Hubble are essential for providing a complete picture of such extraordinary cosmic events. Imagine standing beneath a vast celestial canvas, gazing at a horizon lit by the first light of dawn, filling the sky with vibrant hues. NASA has shared remarkable images capturing an unprecedented event where a star known as Betelgeuse shed a large portion of its outer shell, releasing an immense quantity of its mass into space. This extraordinary occurrence is categorized as a surface mass ejection, SME. According to NASA, the amount of material expelled by Betelgeuse was 400 billion times more massive than an ordinary solar flare from our Sun. Scientists have referred to this event as witnessing stellar evolution in real time, with a star throwing off enormous pieces of itself. However, this massive explosion from the super-red giant raises questions and challenges many of the foundational principles we hold about the cosmos. What prompted Betelgeuse to shed such an immense portion of its outer layer, and what does it mean for the universe at large? Let's embark on a detailed exploration. Stars are often grouped into recognizable constellations that draw inspiration from myths and legends, guiding humanity in navigating the night sky. Even today, these constellations remain vital to various cultures around the world. Among these stars is Betelgeuse, one of the brightest and most massive stars visible to the naked eye. Betelgeuse, the stunning ruby-red supergiant, resides in the upper right shoulder of Orion, often depicted as the hunter in ancient mythology. When observed closely by astronomers, Betelgeuse is identified as a highly dynamic entity with a pulsation cycle lasting 400 days, exhibiting dramatic fluctuations in brightness. Its distinctive reddish-orange glow makes it easily identifiable, standing as a vivid example for skeptics who challenge the idea that stars can display a wide range of colors. Known also as Alpha Orionis, Betelgeuse is the second brightest star in the Orion constellation, just after the blue supergiant Rigel. Although Rigel is more luminous, Betelgeuse earns the title of Alpha Orionis because of its intensity, size, and color, making it one of the most recognizable stars in the sky.